of limits. Now we'll discuss some standard limits which are going to use in the topic. So we'll start with the most important and the most common use limit, which is the ratio of sine of angle and the angle. Okay. Now beware that these angles are in radians, right? So this is the limit of this ratio sine x upon x as x approaches 0. So as the angle in radian diminishes, what does this limit approaches to? And this limit approaches to 1. Now the proof of this limit is quite typical and it can be done by squeeze theorem, but we don't need to do that. So you just have to remember that limit sine x upon x is equal to 1. So this means that if you have an angle theta, so limit theta approaches to 0, sine theta upon theta, this will always come out to be 1. Okay. So there's one more thing which we discussed last time, that was left hand limit and right hand limit. Right. Now see, as you put the value of x is equal to 0, this becomes sine 0 upon 0. Right. And we know that sine 0 is 0. So this will become 0 upon 0 form, which is indeterminate form. So that's why its value cannot be calculated, but its limit can be calculated, and that came out to be 1. Right. Now see, there's one more thing which we need to discuss here, that what is the left hand limit and what is the right hand limit. Of course the left hand limit and the right hand limit will be 1 only, but you need to see one thing, that in case of left hand limit, which is denoted by 0 minus sine x upon x, this comes out to be a little less than 1. So this will be 1 minus 0.0000 something. So when I take the greatest integer function of sine x upon x, so when I take the greatest integer function of limit sine x upon x, this will come out to be 0. So that's the thing which we need to note right now, that this limit is of course equal to 1. Okay, if this limit is of course equal to 1, but this limit is a little less than 1. So when we take the greatest integer function of this limit, this comes out to be 0. Okay, but in the case, now see, if this limit sine x upon x is equal to 1, the limit x upon sine x, should also be equal to 1 only, and it is equal to 1. But there's one more thing, we have to see where does this limit occur. Is it on the right side of 1 or the left side of the 1? Now this limit is a little greater than 1. So when we take the greatest integer function here, limit x tends to 0, x upon sine x, this will come out to be 1. Okay, no doubt. So what I'm trying to tell here is that you need to note these 3 important things, that no doubt limit x tends to 0 sine x upon x is equal to limit x tends to 0 x upon sine x is equal to 1. But this limit is a little less than 1 and this limit is a little greater than 1. That's why when I take the greatest integer function of this limit, this will come out to be 0, and the greatest integer function of this limit x upon sine x, this will come out to be 1. So that's the thing which you need to note. The next limit, the next standard limit is this one, that what is limit x tends to 0 cos x. Now as x tends to 0, we know that cos 0 is 1. Okay, so this limit is always equal to 1. Right? Clear? So limit x tends to 0 cos x is nothing but it is equal to the value of cos 0, and that is equal to 1. So now we have learned 2 limits, sin x upon x and cos x. Now if I try to see this important limit, limit x tends to 0 tan x upon x. Now this limit can be written as sin x upon x into 1 upon cos x. So this is the product of 2 limits. limit x tends to 0, and this will come out to be 1 also. So limit sin x upon x is equal to limit tan x upon x is equal to 1. So these are some standard limits linked to the trigonometry. Let's do a question on this one. Can you tell me what is the value of sin 3x upon x when limit x tends to 0? Of course, we cannot calculate the value of this expression sin 3x upon x when x is equal to 0 degrees or 0 radians, because we know that both numerator and denominator are coming out to be 0. And this is a 0 by 0 form which cannot be calculated. That's why I am putting a limit over here. The limit x tends to 0 sin 3x upon x. Now this limit, now we know that if this angle is here and the same angle is here, this limit will come out to be 1. As we discussed that sin theta upon theta, and when limit theta tends to 0, this is equal to 1. So what I'll try to do here is that limit x tends to 0, this can be written as sin 3x upon 3x multiplied by 3. I just multiplied it and divide by 3. This limit will come out to be 1. As discussed that limit x tends to 0, sin theta upon theta is equal to 1. And this will be equal to 1 into 3. So this limit comes out to be 3. So the answer of this question is 3. So let's do one more problem on this one. Can you tell me what is the value of limit x tends to 0 degrees 1 minus cos x upon x squared? So this is a very important question. It is generally asked in many examinations. So first, let's try to see what is the value of this expression at x is equal to 0 degrees. When we put the value of x is equal to 0, this thing will become 1 and the denominator will become 0. So this is in fact a 0 by 0 form. So what we need to do is we have to operate on the limit of this expression. So how can we do that? A simple way is applying the trigonometric identities. So see that 1 minus cos x, as we have already learned, this is equal to 2 sin square x by 2. Right? So 1 minus cos x can be written as 2 sin square x by 2. If somebody doesn't remember this, you have to go to the multiple and sub-multiple formulas of trigonometry. Okay, then it will be clear. So this can be written as 2 sin square x by 2 divided by x square. Now this is the expression we are dealing with right now. Now we know that this thing can be written as sin x by 2 divided by x by 2 whole square. Right? This can be written as sin x by 2 divided by x by 2 whole square. If I am making this like this, I have to multiply this expression by 1 upon 4 because I am dividing this by 1 upon 4. Right? To introduce this x upon 2, I had to divide this by 1 upon 4. So I am multiplying here by 1 by 4 and this thing will become 1. Now limit x tends to 0, sin theta upon theta is equal to 1. So this will come out to be 2 into 1 upon 4, which is nothing but half.